In this video I'm going to talk about arithmetic series. So remember that a sequence is arithmetic if it has a pattern that's adding or subtracting, or it has a common difference that we call D. And a series is anytime I have a sequence and I take the sum of the terms in the sequence. So for example, here it says find the sum of the following series. I've got 1 plus 2 plus 3 plus 4 all the way up to 10. So we can see that this is increasing by 1 every time. So the common difference, D, is 1. Therefore, it's an arithmetic sequence that I'm adding up all the terms, so it's an arithmetic series. If I want to find the sum of an arithmetic series, I've got a few ways that I can do that. Either I can do it by hand and add 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 10 and see what I get. Another strategy could be to, I'll write this kind of over here as a side note, write a summation if you have your calculator, and you could say that we're going from the first term all the way to the 10th term, and we would just have to write our explicit formula for this sequence, which would be A1 is 1 plus D is 1 times n minus 1, or something like that. So if we type that into our calculator, we should get the same thing as well. The other option that we have is our formula for an arithmetic sum, and that is that the sum of n terms should be half the number of terms times the first term plus the last term. And we have all of that information, so we could also just find that sum by saying 10 over 2 times 1 plus 10, which should be pretty quick even if we don't have a calculator. So 1 plus 10 is 11, and 10 divided by 2 is 5, so I have 5 times 11, or 55 as my total sum. Cool. Okay, let's try another one. This one's a little bit bigger, so it's a little bit harder to do by hand because I want the 31st partial sum of the series, which could get a little exhausting finding all 31 and adding them by hand. Again, if you wanted to write some sort of summation, you could set that up. But let's say again that we are no calculator, we're doing this by hand, and we want to practice using our sum equation. We'd find the 31st partial sum by taking half the number of terms, so 31 over 2, multiplying that times the first term, which I have, which is 5, plus an, which is my last term, which it looks like I'm not given. So I'm going to need to take a second and find that last term before I can keep going on. My last term should be, since I'm going up to the 31st term, A31. So I can find that by writing my sequence formula for this and then plugging in 31. So I'd take the first term, 5, plus my common difference. Let's see what that would be. That would be 3. So plus 3 times n minus 1, which since we said we're on the 31st, we do 31 minus 1. So I end up with 5 plus 3 times 30, or 5 plus 90, or 95 as my last term. And let's go plug that in here. So the 31st partial sum would be 31 over 2, or 15.5, times 5 plus 95. 5 plus 95 is 100, and 100 times 15.5 would just move that decimal place 2 places, so we'd have 1,550 as our total sum. So lots of options for finding partial sums, either by hand if it's not too many numbers, if you have your calculator by writing a summation and finding the explicit formula, but a lot of times non-calculator, your best option is going to be to use half the number of terms times the first plus the last term.